My name is Jay Love with Hanna Instruments USA. I'm here to talk about the Hanna Instruments Processing Sanitation System. The Hanna Instruments Processing Sanitation System uses chlorine, and chlorine, when monitored and controlled constantly, can be extremely safe, reliable, effective, and very inexpensive. Let's talk about chlorine. Chlorine is extremely safe. Some examples of how safe chlorine is it's used in our drinking water. It's also used in food sanitation to ensure that the food is safe to eat, poultry drinking water sanitation to improve overall poultry health. These examples also display the reliability of chlorine. Chlorine has been used for over 100 years to purify our drinking water and wastewater, so it's definitely stood the test of time. And why? It's because it's extremely effective. It kills most human and plant pathogens on contact. One example we have of using killing pathogens, some research we've done with Dr. Gent at the University of Connecticut Experiment Station, which was using the Hanna system with chlorine and comparing it against copper ionization and Sanitate, a peroxide type product. The Hanna system using chlorine killed faster and more thoroughly than the copper ionization and the Sanitate with pythium. Chlorine is also very inexpensive compared to some other sanitizers out there. 1 gallon of 12% pool shock will treat 120,000 to 250,000 gallons of water at a cost of less than $2 a gallon. Some examples of actual installations we have out in the field. One is Michael's Greenhouse in Connecticut, who is using a tank system very effectively, as well as Mid-America is using it to clean their flood floor tanks to prevent the spread of pathogens. Creech in Washington is using direct inline injection, and Cedar Valley is also doing direct inline injection, just with very high volume and very effectively. So what is a processing system? Well, let's compare it to the alternative, which would be volumetric. A processing system reads ORP as it doses chlorine. ORP is the oxidation reduction potential. The oxidation reduction potential displays how effective your sanitizer is. It's read in millivolts as the units of measurement, and it's basically reading the free chlorine in line and how hot or how strong the strength of that free chlorine, and for residual control. It is measured with a specialized probe in line, something similar to a pH probe. The probe is linked to a controller, which is then linked to a chlorine pump that is actually adding the chlorine to the line. So this way, if the chlorine is added, an increase in pathogens is introduced, then the probe can sense that reduction of ORP and less free chlorine, and will talk directly to the pump and tell the pump to add more chlorine to increase sanitation. And vice versa. If the water is cleaner, then the system can say less chlorine, so no chlorine is wasted. Why is this important? As well, sanitation requirements are always fluctuating. The demand for chlorine will fluctuate due to environmental parameters, fluctuations in pH, and water quality. Volumetric dosing cannot automatically adjust for changing sanitation needs. What are some of those factors that would fluctuate? One being the biological load, or pathogens, or algae blooms, or organic matter such as peat moss or plant parts that may be introduced into the line or into the tank that will consume chlorine needed to sanitize. In higher months, using a pond or surface water in the hotter temperatures and during higher temps, you'll have more biological growth in your water, more algae, more living organisms in the water that will consume chlorine as well. Dissolved oxygen is important because when the dissolved oxygen is increased into the water, it also will give an ORP because it is also an oxidizer. Usually not strong enough to sanitize the water, but it helps boost the sanitation power of the water when the sanitizer is added to that. The higher the dissolved oxygen, the less sanitizer is needed. Another factor is pH. Chlorine is extremely influenced by pH. At a pH of 8 or a pH of 6, chlorine is 3 times more effective as it is at a pH of 8. pH and alkalinity have been known to fluctuate. Turbidity is how dirty your water is. Things in line or in the water that may be floating, particles, soil, anything that can, organic matter that can consume chlorine. And we remind you that only free chlorine is available for residual sanitation. So a summary of our processing system is a processing system will maintain continuous proper sanitation levels regardless of what fluctuations may occur of the water quality coming into the system. It can monitor that, maintain that, and ensure that the proper sanitation is executed. It uses very inexpensive sanitizers such as bleach. We can also use chlorine gas and calcium hypochlorite, which are also very inexpensive. The startup cost for this system can be from $5,000 to $15,000, which is moderately priced. And this system also uses verification or validation of sanitation through ORP, and only chlorine has a verifiable ORP. Some comparisons to other systems out there. The copper ionization system can be very expensive with the startup cost, and once again it is volumetric only, so it cannot keep up with the demand and fluctuation. UV has no residual, unlike chlorine. The hydrogen peroxide type products, or the pair acids, are also volumetric with no verification through ORP. And chlorine dioxide can be a very expensive sanitizer. Some applications in which this system can be used. One, the flood floor tanks can be sanitized between irrigations to ensure that no pathogen such as pythium is spread between irrigations. A storage tank, water being pumped from a pond or from a well, can be put on a loop to maintain a free residual or clean, or using dosing injectors linked with an ORP monitoring system such as our mini controllers, where it can be constantly monitored and manually manipulated. Here's an example of our tank system where the water in the tank is placed on a loop, and in that bypass loop the chlorine levels are monitored. Chlorine is also injected, and this also gives the grower a chance to aerate his water to increase the ORP through oxidation, through dissolved oxygen. And then downline after the tank is another ORP monitor. This is for safety, to ensure that the chlorine going to the plants is at a safe level. It is not too high. We can use multiple tanks, as with a flood floor situation where you would have multiple tanks, and use one system with those multiple tanks. Here's an example of our inline system, where water would be pumped directly from a source such as a pond or a well, and chlorine injected inline before being sent to the plants for irrigation. In this example, acid injection was used with the Hanna acid injection pH control system before chlorination to ensure that the water was at the proper pH for sanitation. This is our mini controllers, which can be used if manually and volumetrically injecting chlorine to ensure to monitor what your sanitation levels could be through ORP, as well as pH monitoring. So a good sanitation system will not only be a sanitizer, but filtration plus aeration to minimize the use of and the need for the sanitizer to make a very efficient system. Thank you.